Hello and welcome to ESA Pod. I'm Sarah Muirhead. We're reporting today from ESTEC, ESA's Space Research and Technology Centre in Noordwijk, the Netherlands. In May 2007, more than 17 years after the launch of the Hubble Space Telescope, European Hubble scientists met here at ESTEC to discuss their achievements. This gathering took place just a few weeks before the signature of the official agreement between ESA and NASA on the James Webb Space Telescope, considered by many as the successor of Hubble. Today we have the pleasure of speaking to Dr. Duccio Macchetto from the European Space Agency and Associate Director of the Space Telescope Science Institute. We asked him about the contribution European know-how has made to the scientific success of this mission.
Astronomers from Europe are involved in 40% of all the projects, so there is an enormous impact of Hubble on European astronomy and European astronomers on Hubble. So that is what we celebrate.
The perception that the Hubble Space Telescope is a US-only mission is far from being true.
It's definitely not true, and that perception is perhaps more felt by the general public than it is felt by the astronomical community. The astronomers have always felt that Hubble was there just as much as it was for the US astronomers. So there's never been this us versus them theme in the astronomical community. The public had this perception that Hubble was only US, and it's only been in the last 4 or 5 years that we have done a determined effort in the European Coordinating Facility, which is an ESA facility in Munich, of advertising that Europe does have an important role in Hubble and that the European astronomers are making this big impact.
Hubble is considered by many as the greatest space observatory to date. What results did we achieve in Europe?
And it covers everything from looking at the nearest stars and planets to the most distant galaxies in the universe, looking at the whole universe as it expands. But it can pick up perhaps 2 themes in which I think, or 3, in which European astronomers have really made a difference.
Dr. Macchetto stressed the major contribution of Europe in the search for exoplanets.
We are always interested as human beings to know whether other planets exist outside our own solar system. We know that they do, and it's very, very difficult to see them. Actually, we do not see them. We only see the wobble of the star and deduce the existence of a planet. With Hubble, we have actually seen a planet going in front of its star, absorbing the light of its star. And with Hubble, we have been able to measure the atmospheric characteristics. We know it has an atmosphere, and we know some of the characteristics of the atmosphere of that particular planet. This is a first. And actually, there have been a couple of examples like that. There'll be other missions that will, like Corot, which was launched recently, that will search for more of these planets. But it is important to study them, to understand whether they are life-bearing or they have the capability of bearing life. And these are all the kind of questions we want to study with Hubble. And European astronomers were those who made those studies and discoveries.
Secondly, Europe was extremely active in studying how the universe evolves.
Hubble was named after Professor Hubble, who studied the expansion of the universe in the 1920s. He was the first one to measure that the universe was expanding. With Hubble, the Hubble Space Telescope, the objective was to measure the velocity of the expansion of the universe. That program has been done by a number of European astronomers. And the big discovery has been not only that the universe is expanding, but it's actually accelerating. This was totally unknown by anybody, although there was a prediction by Einstein about 100 years ago that this could be so. But he thought that that was his biggest mistake, and so Einstein said, no, this is a big mistake. From my equations, the universe is expanding by a constant rate. It's not accelerating. It is accelerating, but we only discovered it thanks to Hubble.
Dr. Macchetto also highlighted the discovery that all galaxies host massive black holes at their cores.
With Hubble, we have not only discovered that black holes exist in a few galaxies, but black holes exist at the center of all galaxies. And this is totally new. Once again, many European astronomers, and once again I'm part of that kind of research, have participated and continue to participate in this study. And it is important because since black holes exist in the center of the whole galaxy, there is another correlation. The bigger the galaxy, the bigger the black hole. The bigger the black hole, the bigger the galaxy in which it is. Somehow, a bigger galaxy knows that it has to have a bigger black hole or vice versa. And that tells us that when the galaxies were formed, they were also forming black holes. And it also tells us what kind of processes give rise to that combination of bigger galaxy and bigger black hole. It gives us a much better understanding of the whole process of evolution of the galaxy since their formation to date.
The next Hubble servicing mission will take place in September 2008 to repair and improve the observatory's capabilities.
The combination of the new hardware and the new instruments that are going to be installed next year are going to make Hubble a new telescope. This is the power of all the servicing missions we had so far. We had 4 servicing missions, and every time that the servicing mission was was completed, the achievement of that mission meant that the Hubble was actually newer in the sense of its power, more powerful than before. If all that is foreseen is going to be accomplished by the astronauts, then we can expect another 7 or 8 years of at least of excellent lifetime.
Dr. Macchetto went on to talk about what will come next.
Hubble is unique. We are building the James Webb Space Telescope. By we I mean ESA and NASA. It's a collaborative project just as Hubble is. And therefore there is going to be a bigger telescope in space than Hubble. But that bigger telescope is going to work in the infrared. So the most distant objects in the universe are emitting radiation in the visible where they are, but we see it as infrared radiation. And so we have to look at the infrared to see and observe and study these objects, the earliest objects in the universe. We also want to study with James Webb the nearby stars and their planets around them, because a contrast between the light of the star and the light of a planet is bigger in the infrared than it is in the visible. So those are 2 fields in which James Webb is going to be unique. But Hubble will remain unique as the only optical telescope in space. Even if we launch the James Webb telescope on time, which we all hope we do, and we have Hubble, they will be able to do complementary science.
He concluded with a message for the future scientists.
The fun part of science and the rewards of science are really great and unique. And they're not just great and unique for astronomers or engineers that work in space. They are also great for people who do software. We have a lot of fun building the stuff that we do for science, for astronomy, or for telecommunication satellites. Our engineers, and we all go through the grind, but at the end of the day, we really have fun in doing what we do. And that is the only message I would like to give to the young people.
For ESAPod, I'm Sarah Muirhead. For more news and information on the World Wide Web, access www.esa.int. Thank you for watching.